Hello everyone, and welcome back to cloud1software.com. I am Dr. Kenneth Oramili. Today, we're diving into the nuts and bolts of HTTP and HTTPS authentication. We'll cover everything from HTTP Basic Authentication to the secure handshake of HTTPS, and even take a look at the historical SHTTP method. Let's get started. In today's session, we're breaking down two main authentication processes. One that's very basic but widely used in legacy applications, and one that underpins secure web communication today. By the end of this video, you'll understand how your browser handles secure connections, how credentials are transmitted, and why protocols like HTTPS have become the standard. Let's start with HTTP Basic Authentication. This is a simple method used to verify a client's identity, typically using a username and password. Here's how it works step by step. Client request. The client sends an HTTP request to access a protected resource on the server. Server challenge. If the resource is protected, the server responds with a 401 unauthorized status and a www authenticate header. This header tells the client that it must use basic authentication, often including a realm that describes the protected area. Client prompt. Your browser automatically displays a dialog box asking you to enter your username and password. Credential encoding. Once entered, the browser combines the username and password using a colon, like username password, and then base64 encodes the result. Authorization header. The client sends a new HTTP request that now includes an authorization header. This header looks like authorization, basic key, QWEX, cha, Z, RP, B, P, Vs, G, V, IHN, L, C, F, T, U, Chi, where the string is the base64 encoded credentials. Server verification. On receiving the request, the server decodes the base64 string and checks the credentials against its user database. Access granted or denied. If valid, the server responds with a success status like 200 OK. If invalid, another 401 unauthorized is sent, prompting for credentials again. Remember, base64 encoding is not encryption. It only obfuscates the data. This means that unless you use a secure channel like HTTPS, your credentials can be intercepted. Now let's switch gears and see how HTTPS ensures the security of your connection. When you access an HTTPS site, a series of steps known as the SSL/TLS handshake takes place. Client initiates connection. Your browser sends a client hello message listing the supported cipher suites and TLS versions. Server sends certificate. The server replies with a server hello message, including its digital certificate. This certificate contains the server's public key. Certificate verification. Your browser then checks this certificate against a list of trusted certificate authorities, CAs, to verify the site's authenticity. Key exchange. If the certificate is valid, the browser generates a random symmetric key, encrypts it with the server's public key, and sends it back. Server decrypts. Key. The server uses its private key to decrypt the symmetric key, and now both parties share this secret key. Encrypted communication. From here on, every bit of data exchange is encrypted using this symmetric key, ensuring privacy and data integrity. Data transfer. This secure tunnel remains active for the duration of the session, after which the temporary session key is discarded. This handshake, which relies on both public key cryptography and temporary session keys, is what makes HTTPS so robust against eavesdropping and tampering. Before HTTPS became the go-to standard, there was SHTTP, or Secure HTTP. Let's take a brief look at how SHTTP Basic Authentication works and how it compares to both HTTP Basic and HTTPS. What is SHTTP? SHTTP was developed in the mid-1990s to provide security services such as confidentiality, integrity, and authentication for HTTP transactions. Unlike HTTPS, which secures the entire session, SHTTP encrypts individual messages. SHTTP Basic Authentication process. The process is similar to standard HTTP Basic Authentication. The client requests a resource, the server challenges with a 401 unauthorized status, and the client resubmits credentials in the authorization header. However, because the HTTP message is encrypted by SHTTP, the base 64 encoded credentials are protected during transit. Advantages and limitations. Advantages: confidentiality and integrity are maintained, as the encryption protects the credentials from being intercepted. Limitations: like standard HTTP Basic Authentication, the credentials are sent with every request, and there is no built-in session management. In practice, HTTPS has become far more popular due to its broader protection by securing the entire session. While SHTTP is mostly of historical and educational interest today, understanding it helps us appreciate how security measures have evolved. Let's quickly compare these methods and discuss some best practices. HTTP Basic Authentication, plain HTTP, is simple to implement but sends base 64 encoded credentials in plain text, making it vulnerable to interception. HTTPS, or HTTP over SSL TLS, secures the entire session via an SSL TLS handshake, ensuring that data, including credentials, is encrypted. SHTTP historically provided selective message encryption but lacked the comprehensive security and ease of use that HTTPS offers today. Best practices: always use HTTPS when transmitting sensitive information. Avoid storing credentials in plain text in logs or caches. Consider using additional layers of security, such as multi-factor authentication, for enhanced protection. To summarize, we've learned that HTTP Basic Authentication is straightforward but insecure unless wrapped in a secure channel. HTTPS uses an SSL TLS handshake to establish a secure, encrypted connection, protecting all data in transit. SHTTP, while an important historical stepping stone, has largely been replaced by HTTPS due to its more comprehensive security benefits. Understanding these protocols not only gives you insight into how secure web communications work, but it also highlights the importance of using modern, robust security methods for protecting sensitive information. Thank you for watching. If you found this video helpful, please give it a thumbs up, subscribe for more deep dives into web security, and leave your questions or comments down below. Don't forget to hit the bell icon so you never miss an update. Until next time, stay secure and keep learning.